Hello, good morning, students. We are live now. So, Shreyasi has joined. Good morning, Shreyasi. Is my audio and video clear? Nikita, Sanika, Ranjan. Okay. Nikita, Sanika, Ranjan. Okay, so I can see you people have joined. Okay, so let's start. Okay, so we have good strength to start. So we were doing construction, two classes already over. This is the third class of construction. You can see two questions on my, you can see a question on my screen. So let's start. First of all, in today's class, we will do two questions of constructions and then some MCQs and assertion and reasoning based questions we'll do. So let's see what we have to do in this question. Draw a line segment AB. Mark a point C on AB such that AC is equals to 3 centimeter. So we have to draw one line segment AB. So first of all, rough sketch I will draw and I'll show you, I'll give you an idea what we have to do. So we have to draw one line segment AB. What's the length of a line segment AB? 5 centimeter. So AB is equals to 5 centimeter we have to draw. Then we have to mark a point C on AB such that AC is 3 centimeter. So on this line itself we have to mark one point C such that this distance AC or the length of the line segment AC is 3 centimeter. Using a ruler and compass only we have to construct. So this is done. Now we have to construct a circle of radius 2.5 centimeter passing through A and C. So after that we have to construct. So normally for construction of circle what we will do? First of all we will draw perpendicular bisector. First of all what we will do? We have to draw perpendicular bisector. Perpendicular bisector of AC. So perpendicular bisector you all know how to draw. So like this, here we will draw perpendicular bisector of line AC. Then we have to draw a circle of radius. Then circle of radius 2.5 centimeter we have to draw. So from here to here, we will see, because the radius of the circle should be 2.5. So at this point we will see we'll open our compass of length 2.5 centimeter and we will draw one circle. The circle should pass from the points A and C. So like this we have to draw. First of all, let's draw till here. Then second point we will do. So I hope the first point is clear. So rough sketch I have shown you, like this we are going to do. So in the construction screen, I won't be able to write anything. So you have to name everything like the way I have done here. So let's start. So is my construction screen visible now? Yes. So first of all, what we have to do, we have to draw a line segment AB of 5 centimeter. So that's the first thing we have to do. So I'm just going to draw one line segment AB with the help of scale and pencil. We have to do. See, your pencil should be sharp. So one line segment I have drawn, the length of the line segment is 5 centimeter. So you can write here, name of this one is AB. AB you can write. After this, we have to draw a line segment AC. On this line itself, the length of AC is 3 centimeters. So I'll just draw it with difference. So on that itself, you have to draw. On line AB itself, you have to draw one line segment AC, and the length of the line segment AC should be 3 centimeter. So with different color I have drawn, I hope you can see. So AC is 3 centimeter. So after this we have to, the line with red color which I have drawn, that is line segment AC. The length of this line segment is 3 centimeter. Now we have to draw circle whose radius should be 2.5 centimeter. For that, first of all, let's draw the perpendicular bisector. So yesterday also we were doing similar type of questions. So whenever from line we are drawing circle, we are first of all drawing the perpendicular bisector of that particular line. So for AC is perpendicular bisector, I am going to draw now. So perpendicular bisector, we all know how to draw. At point A, I am keeping my compass and one arc up and one arc at the lower side of line AC. Then I am keeping my compass at point C, one arc. The compass radius should be same which you have taken previously. One arc up and one arc at the lower side of the. One second, I'll just. So I have to open compass. I have to keep at point C. I have to open compass more than half. For perpendicular bisector, I have to open compass more than half of line segment AC. I have to adjust it, and with C point as center, one arc up and one arc at the lower side. With A point as center, same compass radius, one arc at the lower side and one arc at the upper side I have to draw. Both the arcs should cut each other. Both the arcs should cut each other. Point of intersection we will use to draw the perpendicular bisector. So you can see I have drawn the perpendicular bisector of line segment AC. So this part is done. After this we have to construct a circle of radius 2.5 centimeter. Now circle of radius 2.5 centimeter we have to construct. So compass I am opening The radius of the compass should be 2.5 centimeter, because here we have to construct one circle whose radius should be 2.5 centimeter, and the circle should pass through A and C. The circle should pass through points A and C. So I have opened compass of radius 2.5. Now here at this point on this line you have to keep. I'll just extend this line, because at perpendicular bisector I have to keep my compass one end point, and the other end of the compass you have to keep at the vertex A. Like this, you have to adjust compass in such a way that sharp end of the compass, you have to place at the perpendicular bisector, and other edge it should be at point A. So I'm just going to do this adjustment. I'm just doing the adjustments. You can see like this I have to adjust. On this line, on the perpendicular bisector, you have to keep your compass, and now you can draw the circle. 1 second. One second, I'll just redraw this part because it's not coming properly. First of all, I have drawn one line segment. I've drawn one line segment of length, line segment 5 centimeter. After that, on the same line itself, I've drawn a line segment AC of 3 centimeter. Now we have to draw the perpendicular bisector of AC. So perpendicular bisector of AC I am constructing now. After that, I have to construct a circle of radius 2.5 centimeter. So I'll open my compass of radius 2.5 centimeter. 2.5 centimeter. So it's almost 2.5 centimeter. OP is equals to, so okay. At this point, I am just cutting one arc at perpendicular bisector. I am just cutting one arc. So this is perpendicular bisector. At perpendicular bisector line, I am cutting one arc. At a distance of 2 point. So here we will mark the center of the circle. Now I am keeping my compass at this point. See, first of all, I have drawn perpendicular bisector. After drawing perpendicular bisector, I have to draw a circle of radius 2.5 centimeter which should pass from A and C. So I opened my compass of radius 2.5 centimeter, and from here I have marked one arc. Now at this point, with point O as center, I am drawing circle, and you can see circle is passing from point A and C. I'll just show you what I have done. After drawing the perpendicular bisector of AC with A as center, I cut one arc at this point. The length of this was 2.5. Now this point I have marked as point O. This point I have marked as point O. With point O as center, now we have drawn one circle, and this radius, this circle is of a radius 2.5 centimeter, and you can see this circle is passing from point A and point C. So first part of the question is done, circle is done. Now what we have to do? We have to construct two tangents to the circle from the external point B. So point B is here. From this point we have to construct two tangents to the circle. So for construction of two tangents, what we have to do? Again we have to use the concept of perpendicular bisectors. Now as we have to construct from point B, so we will draw perpendicular bisector of line AB, because from point B we have to draw two tangents. So perpendicular bisector of AB we will do. So after doing perpendicular bisector of AB, so we will get one more circle which will intersect the previous circle, and their point of intersection we will join with point B. So this is how the final figure will be. So let's draw now a circle. Let's draw two tangents from point B. So you can see my construction screen now. So I'm just going to construct the perpendicular bisector of AB now. So here this is point B. Point B you can see now. So I'll adjust my compass. Compass should be opened now more than half. So perpendicular bisector of AB I am just going to draw. Perpendicular bisector, now you all know how to draw. Now my compass is at point A, one arc upside and one arc at the lower side I have marked, and I have drawn the perpendicular bisector of line AB. Of line segment AB, I have drawn perpendicular bisector now. After this, again with the help of compass we have to draw, but the radius should be this one. You have to keep your compass at the perpendicular bisector. Now the red color, with red color I have drawn. You have to open your compass till point B or A. One end of the compass should be at the perpendicular bisector which we have drawn just now, perpendicular bisector of AB, and other end should be at any of the point, either A or either B. So with this radius now you have to draw the circle. The circle will pass from point A and B. So this is the red colored circle. The circle is passing from point A and point B. So now you can see this circle has a, both the circles they are intersecting at some point. Both the circles they are intersecting at some point. So their point of intersection here, this is first where they are intersecting, and the second point where they are intersecting. This one. Let's see. Mm, See, I have to draw the from PS center. One second, some mistake. I think it's there. I'll just check. Once again, I'll just do it because there some mistake is there. The circle should be like this, as you can see here. From this point, tangent should be like this, so that both the tangents should be same in length. So construct two tangents to the circle from external point B. Measure and record the length of the tangents. Okay, we'll do one thing. We'll join first of all point O with point B. We'll join point O with point B. See here, this is the rough sketch which I have drawn. So here we got point O, and here this is the point B. Because when we are drawing the perpendicular bisector of AB, the circle is like this. We don't want the both the circles should be like this, so that we can find their point of intersection and we can draw the tangents. So for that, what I am going to do now, I am just joining O with B. So here we have O point and here we have B point. This point is point B. So OB I am joining. Then I am just drawing the perpendicular bisector of OB. Because straight circle we need So the green color line is OB. So OB is perpendicular bisector. I have to draw. Compass should be open more than half. One arc at the upper side and one arc at the lower side. So perpendicular bisector of OB I am drawing now. So you can draw the perpendicular bisector of OB. So I've drawn the perpendicular bisector of OB. Now here with this radius, you have to take this radius 1 point. The sharp edge of the compass you have to keep at the perpendicular bisector and other edge of the compass you can keep at point either at O or B. And then with this radius you can draw the circle. Now we can see both the circles, they have common point of intersection with the circles, so we can just join them. With green I have so two tangents I am drawing now, you can see. From point B you have to draw tangent, and wherever you see both the circles they are intersecting with A as center and with radius 2.5 centimeter. Nikita, PB and PQB are the required tangents to the. Okay, so what is the length of PB and QB? Here any point you can mention, P and Q you can mention. So at this point you can just mention it as point B, as point P, and here you can mention as point Q. So measure the length of PB and QB. So what's the length of the tangents you are getting? Both the tangents, they are equal. The length of the tangents from the external point are equal. So if you have drawn along with me, you can just mention what is the length of tangents you have got. I don't see any comments today, only Nikita is answering. Am I audible? Am I audible? 3 centimeter. Okay, so 3 centimeter is the length of tangents you have got. I hope everyone is getting safe. So here you can mark point P and here Q. So PB, QB, they are equal and the length is 3 centimeter. Okay, let's do next question. This question only took long time. So next question you can see. Before doing multiple choice questions, one more construction question we'll do. Then few MCQs we will discuss. Construct a triangle with the following data. So AB is 3.5, BC, AB, BC, this 3.5, this is 6 centimeter, and angle ABC. ABC means angle B is given to us. This is 120 degree. So like ABC, I have told you middle one is the angle. So angle B is given to us 120 degree. So that's why baseline BC we will draw. First of all, BC we will draw. BC is 6 centimeter. Then we have to construct here at point B an angle of 120 degree. Then here we will get point A. So AB's length is 3.5. So at a distance of 3.5, we'll cut one arc at this line and we'll join. So this is the required triangle. So first of all, let's draw triangle. So triangle I am going to construct. So my construction screen, I hope you can see. So I'm just going to construct triangle. So it's given to us BC baseline, which is 6 centimeter. I'm going to draw. So BC is 6 centimeter. This is line BC and the length of the line segment BC is 6 centimeter. So I have drawn line segment 6 centimeter. Line segment BC, you can name it. So after this, we have to construct an angle of 120 degree at point B. So angle of 120 degree, you already know how to draw. I'm just going to do it. So one arc from this point, then, so I've already taught you, I'm just going to do it now. So at point B, we have to construct an angle of 120 degree. So that construction is done. So we can check also whether the angle is correct or not. So with the help of protractor, you can check. So here my angle is correct. It's 120 degree. Exactly 120 degree. I hope it's visible. After that, now here on this line we will get A point. So AB's value is given to us. Length of the line segment AB, it should be equals to 3.5. Length of the line segment AB, it should be equals to 3.5. So I'll open my compass of length 3.5. The compass should be open. The length of the compass should be 3.5. So few adjustment here you can do. So compass length is 3.5 with point B as center and on this line. The line which is making an angle of 120 degree. At this line we will just mark one arc. This arc is at a distance of 3.5 centimeter from point B. You can see compass length is 3.5 centimeter. Now we'll just join. We'll join this one, this point with this point C we can join. So this is the required triangle. This is the required triangle. So triangle construction is done. Now what is the second thing we have to do? The second thing which you have to do, you can see the question on my screen. In the same diagram, draw a circle with BC as the diameter. So with BC as the diameter, you have to draw one circle and find a point P. So circle, if this is a diameter like this, it will come. If this is a circle with BC as diameter, the circle will pass from point B and point C. Draw a circle with BC as diameter. Find a point P on the circumference of the circle which is equidistant from AB and BC. Point P which is equidistant from AB and BC. So first of all, let's draw construction. Then I'll tell you here what we have to do. So circle with BC as the diameter. Circle with BC as diameter. So that is easily we can do that one. So if BC we have to take as diameter, first of all we'll draw the perpendicular bisector of BC. Perpendicular bisector, if we get exactly central point we will get. So first of all let's draw the perpendicular bisector of BC. Perpendicular bisector, now I am not explaining. We all know how to draw. So I am just going to draw the perpendicular bisector of BC because I want to get the center of the circle. I want to get the center of the circle. So for finding center of the circle, I am just constructing perpendicular bisector of BC. So I've drawn perpendicular bisector of BC. Now I can keep my compass at the perpendicular bisector. You can see I have placed it. Now this is the center of the circle. So one edge of the compass should lie at this and the other one should lie either at B or C. Now we can construct circle. So you can see circle construction is done. So we can do it with some other color so that so the circle is passing through point B and C. Circle is passing through point B and C. So it's visible. I hope you can see. So this is the circle which is passing from point B and point C. So circle is done. Now what is the next thing we have to do? The next thing which we have to do, now they're telling we have to find point P on the circumference. This is the boundary of the circle is known as circumference of the circle. So on this we have to find point P which is equidistant from AB and BC. So AB and BC are two lines. Whenever you have to find the equidistant from two lines, you have to draw the angle bisector. You have to draw angle bisector whenever you have to construct equidistance point or locus of the point which is equidistant. Any one from two lines. So we will draw the angle bisector of this angle B which is present in both. That will be the angle. We have to draw the angle bisector. With the help of angle bisector we'll get the point which is equidistant from two lines. So let's draw the angle bisector of angle B. So you can see my construction screen. So here we have angle B. Angle B you can see which is 120 degree. So I'll draw the angle bisector of angle B. Angle bisector also I have taught you. So compass first of all you can adjust any radius you can take here. So on the end points of the angle, you have to keep your compass. Compass should be kept at the end points of the angles. Here you can see. And now arcs you have to draw. One arc from this end point, the other arc from this end point. So both the arcs they will intersect each other. Both the arcs they will intersect each other. So one arc from this end point, the other arc from this end point. Both the arcs they will intersect at one point. Now you can just draw this one. So angle bisector of angle B I have drawn. Angle bisector of angle B. Angle bisector of angle B you can see I have drawn. Now here at this point P we will get. At this point where there I am just marking it. So this is the point P on the circumference of the circle. Here you can see this point is lying. I have just highlighted it with different color. This point is point P which is lying on circumference of the circle and this is equidistant from AB. So AB is this line is AB and this line is BC. So this is equidistant from AB as well as from BC. So this is the required construction. Yes, 30 degree is the angle bisection of the 30 degree. Yes, it should be 60 not 30. Angle B is 120 degree. Its angle bisector when we will draw, it will be 60 degree. You can see it's not 30 degree. So if anyone has any doubt, you can just ask me. Here so many construction questions we have done. From last two classes we were doing. So mostly all the concepts regarding constructions I have completed. Now few MCQs we will do and then we'll just complete this topic. Instructions will be completed then. Yes, you can see first question on my screen now. So MCQs we are going to do now. So what is the first question? You can answer along with me. So while constructing a tangent to a circle from an external point, which of the following steps is correct? Yes, so which option will be correct? While constructing a tangent to a circle from external point. So construction of tangent from external point we have done. So suppose from this point if we have to construct a tangent like this it will come. So which option is correct? Draw a line segment from the external point to circle's center. Use a compass to draw the arc from an external point intersecting the circle at 2 points. Draw a line segment from the circle's center and perpendicular to the radius. So line segment we can draw a line segment from the center and perpendicular to the radius, and use a compass to draw an arc from the external point intersecting the circle at single point. So which option is correct? We have already done now. So tangents. So use a compass, option D. Shreyasi has mentioned option D. So use a compass to draw an arc from the external point. So from external points only we are actually drawing the arc. Arc means in the sense of complete circle actually we are drawing. So which should intersect a circle at a single point. So option D is the correct option. So the arc should intersect the circle at a single point only. So option D is the correct option. So you people only have answer. Let's do next question now. When constructing a tangent to a circle from an external point, what is the relationship between the tangent? This is very easy. While constructing a tangent to a circle, what's the relationship between tangent and radius? So this is a circle, this is the radius and this is the tangent. So what is the relation? They are perpendicular to each other. They form an angle of 90 degree. They intersect at 2 points. They are parallel to each other. So which option should be the correct one? So I have shown you also which option should be correct. Option A. Yes, so I have shown already here also. So always they are perpendicular to each other. The radius and the tangent at the point of contact, they are perpendicular to each other. So option A, and this result we use many times when we do the questions of tangents and intersecting chords. So radius and tangent, they are perpendicular at the point of contact. So here is the point of contact of the tangent. So they are perpendicular. So option A as given by Nikita, Jayashree and Shreyasi. When Sanika has given the answer. Let's do next question now. So questions are not very difficult. I want you to answer the questions. We have done now practically all the constructions we have completed. So in constructing a circumscribed around a triangle, so which geometric principle we use? Yes, so we use the concept of Nathan has given the answer A, Pythagorean Shreyasi, option D. Option D is the correct answer. See, circumscribed circle means outside. The circle which is passing from the vertices. Circumscribed circle, like the circle which is passing from the vertices of the polygon. So in case of triangle, it is passing from the vertices A, B, C. So here we use the concept of perpendicular bisectors. We use the concept of perpendicular bisectors. So if I change the concept of circumscribing circle to inscribing circle, then which concept will come? For circumscribing circle, option D is correct. But if I change the question from circumscribing to inscribing, then which option will be correct? Yes, so Sajila has given C option. Yes, in that case, angle bisector we use. We use the concept of angle bisectors. Yes. Let's do next question now. Which of the following statement which of the following statement is true about the construction of tangents to a circle from an external point? So which option is correct? This is also today itself we did the question, even yesterday we did. Only one tangent can be drawn from an external point to a circle. Two tangents can be drawn, three tangents can be drawn, four tangents can be drawn from external point. So from external point, how many tangents can be drawn? Which statement is correct? Which statement is correct? Today itself we did this question. Option B. Option B. So option B is correct. From external point, two tangents can be drawn. From external point, two tangents can be drawn. So that's why second option is correct. Two tangents can be drawn from external point of a circle. Let's do next question. Which method is used to construct the circle that circumscribing a given triangle? So which concept we will use? I think this is also very easy. The same repeated type of question. To construct a circumcircle, which concept we use? Using the perpendicular bisector of the sides, using the angle bisectors, using the medians of the sides. Yes, so option A, just now we did, only language of the question is changed. So A option, as Navya, Jayashri and Sujila has mentioned, even Avni has given the answer. So option A, using the concept of perpendicular bisectors. Next question. This is very easy question. So in the construction, which of the following tools are used? So which tools we are using here? Full construction. So option, which tool we are using for the construction? A, compass we are using here. We are using compass. So option A is the answer of this one. Let's do next question. What is the number of sides of a polygon formed by the intersection of the points of tangents drawn to the circle from an external point? So what is the number of sides of the polygon formed by the intersection points of the tangents drawn to a circle from which? So how many sides will be there? Polygon means any closed figure. So what is the number of sides? See, from external point we are drawing tangents. So tangents are true. The number of tangents are 2. So what are the, if with the help of this we are getting any polygon, what will be the number of sides? So many times we have done question like this. If we complete the polygon, we'll get number of sides equals to 4, 6. No, it should be 4, because the question says if with this condition we are drawing the polygon. If this condition we are drawing the polygon, like when the tangents are drawn from same external point, here see it's mentioned by the intersection of the point. So how many we will be getting? 4, four-sided polygon. Let's do next question. Which construction method is used to draw tangent? Which construction method is used to draw tangent to a circle from external point? Tangent to a circle from external point, how we are drawing? This is simple question. With the help of compass and ruler we are doing. Any other rule is not there, because one, how we are drawing? Which construction method is used to draw tangent to a circle from external point? So using ruler and compass. The three vertices of a scalene triangle are always equidistant from a fixed point. Three vertices, they are equidistant from a fixed point. So if these are the three vertices A, B, C, these are at a fixed point. This distance is equals to this distance is equals to this. AO is equals to OB is equals to OC. Then what is the name of this point O? What is the name of this point O? Is it orthocenter, incenter, circumcenter, or centroid? Option B. Option D. Option D. See, centroid is that point which is the point of intersection of all the medians of the triangle. So that is centroid. Centroid is not that point which is equidistant from the vertices, because centroid it divides this line in the ratio 2 is to 3. So 2 is to 3, it should be 1 is to 1, then only it can be equidistant. So centroid is the point of intersection of three medians. Option B, in center. In center also we have drawn. See here, try to understand. The question says in which point AO is equals to OB is equals to the, from one point the vertices are equidistant. So in center we have done the construction of in circle also like this. So in case of in center, so here we are getting this as the radius. We don't have anything to do with the, because angle bisector we are drawing. So this point, this will be point O. So we don't know what is the distance of this point from the vertex. We don't know. So construction we have done of in center also, one of the question we did with angle bisector we do. So here we don't have anything. So Monish has given the answer C. Yes, it is circumcenter. Why it is circumcenter? Because you have done the construction of circle also. So in case of that only you have measured like this. This practically you have drawn. So in that case only AO, OB and OC, they are equal to each other. So this is the circumcenter when three vertices are equidistant from a fixed point. So you should know what is orthocenter, what is incenter, circumcenter and centroid. All things you should know. Orthocenter is the point of intersection of the altitudes. If in a triangle, three altitude means perpendicular lines I am drawing. So their point of intersection is orthocenter. This is orthocenter. Let's do next question now. So next question is assertion and reason based question. So some 2-3 we'll discuss and then we'll just finish this one. So assertion and reason based question. First one, option A is correct, R is false. So these accordingly you have to answer. These are the options. So A is true, R is false, A is false, R is true. Both A and R are true. So both A and R are false. So first one. Assertion, it's possible to construct a tangent to a circle from external point. Is it possible? Is it possible to construct a tangent to a circle from external point? Is this thing possible? You have to tell me, because according to the options we have to answer. A is true. Yes, it's possible. We have done also construction. It's possible to construct a tangent to a circle from external point. So that means A is true. First one is true. This is a construction property of a circle that can be proved using geometric principles also. Geometric principle means like the results of geometry, whichever we know. So the construction property we can prove with the help. Because if I am drawing from external point tangent, if I am drawing, I can draw this one. So this I can prove with the help of geometric principle also. So these are equal. So this thing can be done. So second also it's true. This property we can, this construction of can be proved using geometric principles. So both are true. So option C is the correct answer. Option C. So next one, if a hexagon is circumscribed about a circle, the line joining meet at a point. If hexagon is circumscribed, see hexagon circumscribing we did in first class. This is hexagon, six-sided polygon. So they have mentioned if you are drawing the circle circumscribing hexagon, it will look like this. So the line joining the opposite vertices, this we learnt in symmetry also. So opposite vertices when you join, yes, they will meet at one point. Opposite vertices if you are joining, I'm showing you also. So they are meeting at one point, and this we did while drawing the lines of symmetry also. One second or third question we did. So that means first one is true. When you are drawing a circle circumscribing hexagon and their vertices. Vertices, from vertices, if you are drawing lines, they'll meet at one point. So first is true. If you circumscribe a triangle, square, etc., you draw a circle that surrounds it and touches each of the corner. Is it true? They are telling if you are drawing circumscribing triangle, so it will be like this. Square, if you are drawing, it will be like this. So it's telling you draw a circle that surrounds it, that is true, and touches each of its corner. So we have already done. So that R is false. See, each of the corner it is touching only. It's not each of the corner. In case of corner means vertices. If you are drawing circumscribing circle for any of the polygon, it will always touch its vertices. So like this. So in case of square also it will touch. So both are true. For this also C option is correct. Both are true. I hope this is clear. That's why I am drawing here and I am showing you circumscribing circle. Whenever you draw, the polygon's vertices will be touched by the circle. Always. So this one, second one, first one, both are true. Both A and C are true. And this one now, assertion. The incircle or the inscribed is the largest circle that can be contained in the triangle. Incircle is like this. If this is a triangle, so this is the incircle. This is the incircle. So the circle, this circle is the largest circle that can be contained. Yes, that's true, because see, if you draw a circle which is larger than this, then the circle will become like this. It will come outside. This in circle, it touches the three sides. So three sides are in contact with the circumference of the circle. So that's why this is the largest circle. So first one is true. The center of the in circle of a triangle is called triangle's in center. Is it true? Is the center is known as in center of the triangle? Yes, it's known as the in center only. This is known as the in center of the triangle. So here also both are true. Both A and R are true for this question also. So here we have completed. R is false. No, R is not. In case of in circle, this is known as in center. In case of circumcircle, this is known as circumcenter of the require whatever polygon we are drawing. This is a triangle, so that means this is the triangle's in center. So here also both are correct. So with this we have completed this chapter. I hope you have understood mostly all of the questions I have shared. We have done all types of questions. Three classes I took. If still you have doubts, practice worksheets I will try to share on the Telegram channel, and I'll share the link also on this one also, on this channel also. Okay, so tomorrow we are going to start with the new chapter. The name of the chapter is mensuration, that is cylinder, cone and sphere. So that revision we are going to start tomorrow as usual. 5 to 6 will be the class. If anyone has any doubts, you can tell me, or else you can start leaving, giving me your names. I just want to see the names of the students. So thank you so much for attending the class. I'll see you in my tomorrow's class. Bye and have a great day.